Okay, let's take a look at the first problem, practice problem in 7.7. So the loudness of sound measured in decibels is calculated using the formula L equals 10 log. So I don't see any particular base of the log, so we assume that's common log and invisible 10. And Jack, I was telling class that we will cover 7.7 first, and after we finish, then I will give you guys the link and everything. So just let's focus on the lecture in 7.7 first, okay? Okay, so that L equals 10 log base 10. We don't see the particular base and it's common log, and inside of parentheses, it's I, means the intensity of the sound, and the denominator is 10 to the power of, be careful, it's negative 12 as the power, right? So the L indicates the decibel and the I indicates the intensity of the sound. Then the question is asking, what is the intensity of a fire alarm that measures 205 decibel loud, and round your answer to the nearest 100th, right? Okay. So now the letter L will be replaced by the given decibel value 125. So we can start approaching this one by filling our information there. So the 125 is indicated the loudness of the sound. Then we can put 125 there. Then that's supposed to be equal to 10 and common log. And the intensity of sound is what we are finding. So we will keep the variable I there, and it was down here, it's a 10 to the power of negative 12. And that's it. So now we have to solve this equation, right, for I. So first, as usual, what we do for solving any equations, we simplify anything around the targeted variables, right? So now we notice I is my right-hand side, and we will do mathematical manipulation to both sides so that we can isolate I here. So the first step that we have to do is, I notice there's 10 multiplying, right? So what we can do is we divide both sides by 10. So divide this by 10, divide everything by 10 so that we can get rid of this 10, right? Then next step, 125 divided by 10 is 12.5. Then next step, this is log of I 10 to the power of 12. So if you have this log equation, in order to solve the variable that is positioned as the part of the value, then there's some different ways to solve, but probably its most efficient way will be we convert this one into exponential expression, right? So then if I want to convert it to exponential, now I assume this base will be 10 now from the common log, right? Because it's common log. Then 10 to the power of 12.5. So now it gets 10 to the power of 12.5 is I over 10 to the power of negative 12. 10 to the power of negative 12, right? Negative 12. Then next step, now in order to isolate I, you multiply 10 to the power of 12 to both sides, negative 12 to both sides. Then they happen to have the same base, and you should be able to simplify left-hand side by using product rule. Then you should be able to find I. Okay, I think I already showed you the enough steps for the approach. So I would not go further with just spoon feeding you guys with the answer, but hopefully it helps you guys to navigate through, okay? Any question? Good, okay. Then let's save this. Okay. Then clear. Then let's do compounded interest problem. Okay, Diane's bank is offering 5% interest, compounded monthly. So let's highlight compounded monthly here. Okay, so by looking at this part, that it indicates what kind of formula for us to use. If Diane invests 10,500 and wants $20,000 when she withdraws, how long should she keep her money in for? Round the nearest 10th of a year. Okay, so now, first, since this one gives us a situation that interest compounded monthly. So if we recall the formula, and the formula appropriate for this situation will be the amount. The amount is the principal times 1 plus the rate over how many times it's gonna give the interest over a year, then and again, and then now the part of the exponent indicates the time, right? Okay. So with this, now we can substitute the given information proper positions here. So now the targeted amount is 20,000. So the A, the letter A, is going to be 20,000. So let's write 20,000. Then the seed money, the principal, is 10,500, and it's going to be 1 plus. Then when you input rate, you have to be careful to convert it into decimal. So 5%, so 5% will be 0.5, and the monthly part, that means there's 12 months in a year. So it's gonna have 12 there and close here. Then 12 again on exponent. Then we are finding the t here, okay? So now, by using calculator, you have to be super careful what part of the equation that you properly in the right order you calculate, right? So of course you have to do the inside of parentheses first, right? So inside of parentheses, then even inside of parentheses, you have to be really careful to do the division first and add 1 with your calculator. If you don't utilize the parentheses properly, or you don't punch your numbers based on the right operations order, then it's gonna give you a wrong number. So I calculated the number in advance. Then the next step, you're supposed to have so inside it should be 1 point. If you divide 0.05 by 12, it's 0.00416, and then it's gonna be 12 times t in there. Then the next step, in order to isolate everything else around the t, that you have to divide this principle from the right side. Okay, then next step, the division on the left-hand side will give you 1.9047, and now it's 1.00416 raised to power of 12 times t. Then the next step key will be, since the variable that we are solving for is exponent of exponential expression, the key is you have to do both the common log. Then you can apply power rule so that you can have 12 times t goes in front of the log, right? Then you can further use the values of log of 1.9047 and log of 1.00461 so that you can go find the actual value for t later. Okay, so as I did before, I would not go further to show all the steps until the answer. And I think this is enough guideline for you guys to utilize. But any question though? Okay, then let me save it for your notes. Okay, then let's do one more. Okay, so the one right below is very similar problem here. So let's take a look at this. But the only difference is, instead of it was giving the interest monthly or quarterly, it's numerous countable numbers of time over the year. And what's different in here is compounded continuously, okay? Compounded continuously, let us use the, a little bit different formula that goes, the amount is the principal P, and then the Euler's number, E to the RT. So you have to use this formula properly. Then let's see how we can properly substitute and input the given equation here. So if we utilize this formula, then Lane's parents want $500,000 at the end of 40 years. They are opening an account that yields 4% per year, but compounded continuously, right? So then now we have the targeted amount at the end should be 500,000. Okay, then, so 500,000, and we don't know the principal, so I will keep P there. Then the base E is the Euler's number E. Then the rate continuously compounded is 4%, so it's going to be 0.04, and so now 0.04 times how long do they keep this account? 40 years. So it's gonna be here, right? So then in next step that you will have you calculate the exponent first, right? You calculate the exponent first, then you are solving everything. You will get the value from your calculator if you punch E by using the second key and you punch the natural log key, then it's above the key, it says e to the power of x, right? So then you can properly utilize that key on your calculator so that you get the value of e to the power of, and utilize the parentheses if you are not going to multiply this 0.04 and 40 in advance. Then it gives you a certain value. Then that's gonna divide both sides, right? Then you will get the principal amount, how much that you have to invest in the beginning, right? Beginning of the 40 years, right? Then you're gonna get the value there. Okay, so now this is the targeted variable that we are finding. Then you should be able to calculate e to the power of 0.04 times 40, and then properly. So just get and then divide both sides, right? Okay, then I think this is enough guideline for this problem. Any more question? Okay, then what was next? Okay, then now let's take a look at some simple equations, exponential equations and logarithmic equation really quickly, okay? What kind of problem? Okay, let's take a look at this one. 9 to the power of x is 27 raised to power of x minus 1. And in this case, there's going to be some different ways. You can directly do log base 3 to both sides. Notice 9 and 27, they are the family of multiples of 3. So it might benefit that you do both sides with log base 3. So some simplifying process will happen, right? But I want to show you another method that you can do. Just match the base first, because it's with 9 and 27, it's not so extreme for us to match the base, and then we compare the exponent over the equal sign, right? So we can, so notice 9 is 3 squared and 27 is 3 cubed. So this is simply saying 9 being 3 squared raised to power of x equals to 27 being 3 cubed raised to power of x minus 1. Then by using power rule, so remember the power rule, then the left-hand side will be 3 to the power of 2 times x, 2x. Then the right side will be 3 to the power of 3 times x minus 1. Then here, you can simply compare exponents. So if my left-hand side is 3 to the power of 2x and my right-hand side of the equal sign is 3 to the power of 3 times x minus 1, then they are equal. Then they should have the x value by setting the exponents the same, right? So then we are comparing the exponents, and then it's going to give us 2x. The exponents from the left-hand side should be the same with exponents from the right-hand side. Then this becomes just simple, easy equation solving, right? But since we are using different level of mathematical manipulation, right? So you always have to check your answer, right? In this type of math equation that you get the value for x, right? Then you always have to check back with the original situation, right? So do not forget, check your answer. So okay. Any question? All right, then let's take a look at a little more. Okay, here's two logarithmic equations to solve here, right? So now, let's take a look at log base 3 of 2x is supposed to be same with log base 3 of x plus 12 here, right? Then now I'm checking this. Log base 3 here, log base 3 there. So they're exactly same log base 3 functions here. Then, in order to make true of this function, now we can simply assume the value goes with each of log base 3 should be the same, right? So do not think of this as a cancellation or whatever. We don't cancel anything in this step, but you can mathematically and logically think if they are supposed to be same over the both sides of the equal sign, and the functions that goes with each one separately, same, then the value that we are substituting, we are inputting should be the same, right? Then just simply we can compare here the 2x and the parenthesis x plus 12. So just compare values of logs. Then I can conclude 2x should be identical with x plus 12. Then it's just a matter of simple equation solving, right? Then so apparently subtract x from both sides, it's gonna make x equals 12. Then again, you have to check your answers. So check. So let's see, we already know x supposed to be 12. Then if I plug the 12 in wherever the x here, right? And then x there, it doesn't make the values negative, which was a big restriction for the log. So the answer 12 that we just got for x is totally fine to adopt. So we don't have to do extraneous solution, right? So this is totally fine, okay? Then let's take a look at next one. That will be the last example for today, and we will start IAB soon, okay? Here, now, this takes one more extra steps than what we have above. But what you can do is notice right side has log base 2 added together. So then what we have to apply here is the product property. Condense means if you have multiple logarithms that you can make it into a single logarithm as long as they're the same kind, same base logs, right? Then the next step, it's gonna be 4 is now these are added together. So this is log base 2. We are simply multiplying 2x and x over 2. Then notice this says 4 and then log base 2. And then now we cancel 2. So this is just simply x squared, right? How did it happen? Because we can cancel 2 and 2 there, right? Then now you can utilize here the power property. Or you can even go further here. I mean, you can even go faster. So do not use power property. Then you can convert it. You can convert it as, so next step, you can convert it as this is base 2. this is base 2, then power of 4 is x squared, right? Then this is simply asking 16 is x squared. Then we can do square root both sides, and then it's gonna give us x is plus minus 4 here, right? Plus minus 4. But you always have to check back. So let's check back with these answers. Then positive 4 going in here, and log base 2 of 2 times positive 4 is 8. It's totally fine. And log base 2 of x, which is 4, divided by 2, which is totally fine. But if we utilize the negative 4, that's going to be problematic. Why? Because negative 4 makes the value with the log negative. So you do have extraneous. Check back for extraneous solution all the time, right? So then this is not gonna be the answer, right? So that's why you always have to check your answers with solving exponential or logarithmic equations, okay? Any particular questions, guys?